السلام عليكم ورحمة الله وبركاته. إن شاء الله we're going to start with chapter 17, vectors. The vector is any quantity that has a magnitude and a direction. For example, you have the velocity. You're saying that your car is moving 20 kilometers per hour in the north direction. So here's the magnitude, 20 kilometers per hour in the north direction. So velocity is a vector quantity. However, the speed is not. The speed is just always a magnitude, just 20 kilometers per hour without specifying the direction. We have also many examples for the vector quantities like force, displacement, gravity, pressure, momentum. All of these I think you have studied in physics. Now, wherever you present a vector, you present it with initial point and an end point. Or terminal point. And you're gonna read it like this: AB vector with an arrow above it. Wherever you read any vector, you have to read the angle which is between the x-axis and the vector itself. So the vector, or the direction of the vector, is the directed angle between the x-axis and the vector itself. We have also two other ways to read the direction of the vector, which is the pairing. And the pairing, we have two types of it, the quadrant and the true pairing. What is the meaning of pairing? Pairing means that you are reading the direction with respect to the north. So for example here, this is called the true pairing. You are reading the direction or the angle between the north and the vector itself. So here is the north direction, and here is the vector. The angle between them is, this is 180 and 30, so 180 plus 30 is 210. So it would be here 210. All the time, wherever you measuring the true pairing, you measure it clockwise, so we are moving it clockwise. Let me give you another example here. What if I have this angle, or this is my vector? This is angle like 25 degrees. So I'm reading my direction from north to the vector. It would be 25 degrees. Actually, the true pairing all the time have to be with three numbers. So if you don't have if you have three digits, you have to add 0 here. You put 0 here. So this is the true pairing. So again, true pairing, this means that you are measuring your direction from the north to the vector, or the angle from north to the vector. What about the quadrant pairing? The quadrant pairing is the angle measured between north or south and east or west. What is the meaning of this? Here's the south direction, right? And here's the west direction. I have an angle here, or I have a vector here. So you start from south and moved 30 angle going for west. Let me give you another example here. What if I have this vector? Now I use the quadrant pairing. Now again, the quadrant pairing, you have to start from north and go for east or go for west. So the angle here is not mentioned, so I have to know the angle. Of course, this is 90, so this would be 60. So now it would be north 60, and I'm going towards the direction of east. Let me give you another example to make sure you understand it very well. What if I have this vector? It's 115 degrees. Again, I'm moving from north to east or west. So I have to know the angle between the north and the vector. So this means I have to get this angle. So this means it would be 115 minus 90. So this is 25. So now, how could I write the pairing, the quadrant pairing? It would be north, 25, west. Now we have three major types of vector. We have the parallel vectors, the opposite vectors, and the equivalent vectors. Now, parallel vectors have the same or the opposite direction, but they are necessarily the same magnitude or length. So you have the same length, but maybe opposite or maybe in the same direction. But for opposite vectors, I could call it also negative vectors. They have the same magnitude but opposite direction. For example, if I'm having this vector 2 and 4 and I need the opposite vector for it, I will just give them the negative sign. Equivalent vectors, they have the same magnitude and the same direction. So three major size parallel means that you have the same magnitude but maybe different direction, opposite or the same direction. Opposite vectors or negative vectors, they have the same magnitude but opposite directions. This means I have to change the sign of it. Equivalent vectors, they have the same magnitude and the same direction. Now, if we have one or more vector and we need the resultant vector for that, we have two ways to do the vector addition, maybe the triangle method or the parallelogram method. So let me explain the triangle method for you. Here is vector u. This is the starting point here. This is the tail. And this is the head. The head means the arrow. And here is the vector v from tail to head again. So the resultant vector here should be also from tail to head. So that's why we call it head to tail method. For the parallelogram method, the two vectors would have the same tail. Here is vector v, and here's vector u, have the same tail. And the resultant vector would be the diagonal of the parallelogram, which is this one. Since we're going to complete the parallelogram here, so this would be the diagonal. Now let's go for the vector components. As we agreed, wherever you read the vector, you have to read it from the x-axis, right? So here's a vector. So this is the vertical component for it. And this is the horizontal component for it. And this is the angle which is included between the x-axis and the vector. For example, maybe 30. So if I need this one, so it would be the magnitude of the force or the magnitude of the vector multiplied by the cosine of the angle. If I need the vertical one, this means I need to multiply the magnitude by the sine of the angle. So for example, if I'm giving you a vector with magnitude 50, and the angle here is 30, and I'm asking you, I need the horizontal component. So it would be 50 multiplied by cosine of 30. Or if I need the vertical component, so it would be 50 multiplied by sine 30. And pay attention again, the angle should be the angle between the x-axis and the vector. What if I have this angle? So I have to switch the sine and cosine. Okay? Let's try to solve some problem over the part that we have discussed earlier. The first one, or the first question here, which of the following is a vector quantity? Vector means that we have a magnitude and a direction. So let's see here, a runner completes a 400-meter lap. This is a magnitude, no direction in it. A force of 50 Newton is applied to a box. Okay, 50 Newton and a force. We know that force is a vector quantity, so here's my answer. In the adjacent figure, the vector makes a 40 angle north of east, the correct quadrant pairing of the vector. You remember the quadrant pairing? You start from north and you go for east or west. So here is my north and here is my east. So it's north 40 east. The true standard direction of the vector V. Okay, true standard direction or true pairing starts from the north. And I have to take the angle included between the north and the vector, so this is 60 degree. And you remember that the true pairing should be with 3 digits, so it would be 0, 6, 0. If A and B and C are 3 points in a plane, then AB vector plus BC vector. This is initial point, this is the tail, and this is the head. Tail, head. So the answer would be the tail to the head, A to C. If the vector A equal 4 and -2 and vector B is parallel to A but opposite in direction, then the component form of a vector B is, okay, opposite directions, this means I have to put the negative sign. So it would be like this. -4 and 2. Which of the following diagram correctly represents the resultant vector? So 3x minus y. Good. So here is 3x minus y, just means it's going downward in an opposite direction. So here is y. So my vector should be start from here to here. So this is r. So which one of these matches my vector? This one. The horizontal component of the vector v shown in the figure. Now, remember, all the time the angle should be between the x-axis and the vector, and if not so, you have to you have to switch the sine and cosine. So here, I need the horizontal component, so it would be magnitude times cosine theta. So it would be, the magnitude is 50, and the cosine 60 is half. So 50 times half give me 25 Newton. Now, how could I express a vector in a coordinate plane? For example, here I have a vector AB. The point A is x1 and y1, and the point B is x2 and y2. So, very simple. I need just to subtract the end minus the start. So, x2 minus x1 and y2 minus y1. Let me give you an example here. For example, if I have 1 and 2 and 3 and 5. And I need to get the vector. So it would be here 3 minus 1 and 5 minus 2. So the answer would be 2 and 3. So this is the coordinate for the vector. What if I need the magnitude? The magnitude for the vector or the length of the vector here, it would be a power 2 plus b power 2. What is a and what is b? This is a and this is b. Okay, so I'm just gonna square them and take the square root. So here it would be 2 power 2 plus 3 power 2. So 4 plus 9 give you 13. So it's just the square root of 13. Of course, it's the same if you have the three dimension, x and y and z, for the magnitude and the coordinate plane also. Now let's go for a very simple operation in vectors. It's so easy. For example, here I have two vector u and v, and I need to add them. I'll just add the horizontal part or the horizontal component with the horizontal component, the vertical component with the vertical component. So here, 2 plus 3 and 4 plus 5. So it's 5 and 9. For the subtraction, it's the same. 2 minus 3 and 4 minus 5. So 2 minus 3 is -1 and 4 minus 5 is -1 also. The scalar multiplication means that you're just gonna multiply a number by the vector. For example, if I need to get 2u, so I'll just multiply the vector u times 2. So it would be here 2 times 2 and 4 times 2. So it would be 4 and 8. Let's go to another concept in vectors, which is the unit vector. Unit vector means that you have a vector with a magnitude of 1 unit. And its rule to get the vector over its magnitude. For example, here I have v vector 5 and 12, and I need to get the unit vector for it. So let's get first the magnitude. What is the magnitude? Remember the rule? Square them, then take the square root here. So it would be 5 squared plus 12 squared. So it's 25 plus 144. So it gives me 196, which is the square root for it would be 30. So I got the magnitude. So let's apply the rule here. Where's my vector? It would be 5 and 12 over 13. So it's 5 over 13 and 12 over 13. Here is the unit vector. I could also write vector as a linear combination, which means that if I'm having a vector or a two-dimensional vector, and the direction of the x-axis, it would be denoted by I, and if it was in the y-axis, it would be denoted by J. So here, and it's a small letters. Okay, now, because it's unit vectors, this means it's just only one. So here, it would be 1 and 0 in the x-axis. If it's in y-axis, it would be 0 and 1. What if it was in the z-axis? If we have a three-dimensional shape, it would be k. So it would be like this. This is for I. This is for J, which means that you are in the y-axis. If you are in the z-axis, it would be like this. It would be k. So I want to represent it as a linear combination. This means I'll just write the direction for it. So A in the x-axis, so it would be AI plus BJ, which is in the y-axis, and CK, which is in the z-axis. This is the linear combination for a unit vector. We have discussed earlier the vector component, the vertical and the horizontal component. And as you see here, this is the vertical component, and this is the horizontal component. And of course, if I want to express the vector again, it would be here, the magnitude times cosine theta and magnitude times sine theta, which is A and B. And we get the magnitude by square them and add them and take the square root for them. You remember this, okay? Now, if I need to get the theta, if I have the vertical and I have the horizontal component, I need to get the theta. This means I need to get the inverse of tan of theta. Now, what is the tan of theta? Tan theta equals sine theta over cosine theta, or the vertical component over the horizontal component, which means it's B over A. Now, the theta here has two cases. If the A is greater than 0, you just take the inverse of B over A, tan B over A. But if A is greater than 0, this means that you have to take the inverse tan for B over A, then add 180, which is the pi. So let's try solve some problem over what we have discussed now. What is the coordinate representation for the vector CD, where C is 2 and 4 and D is 7 and 10? So here, let's start and minus start. So it would be here 7 minus 2 and 10 minus 4. So 7 minus 2 is 5 and 10 minus 4 is 6. So my answer is 5 and 6. Okay, now question number 9. If A is 1 and negative 2 and B is 5 and 4, then the unit vector in the direction AB. Okay, do you remember for the unit vector? U equals the vector over the magnitude of the vector. Let's get the vector first. To get the vector, I have to subtract and minus start. So it would be 5 minus 1 and 4 minus negative 2. So now the vector would be 4 and 6. Okay. Then let's get the magnitude here. Sorry, we got them. Here's the vector. Let's get the magnitude. 4 power 2 plus 6 power 2. 4 power 2 is 16. 16 plus 36. So here, 52 is 13 times 4, so I could take the square root for it. It would be 2 root 13. So now let's take, or to apply the rule here. So it's 4 and 6 over 2 root 13. So 4 over 2 root 13 and 6 over 2 root 13. This would be 2 over root 13 and 3 over root 13. What is the component of a vector with magnitude 10 and direction angle 120? Remember, the rule is horizontal component and the vertical component. Magnitude times cosine theta and magnitude times sine theta. So here it's 10 times cosine 120 and 10 times sine 120. Would be here 10 times negative half and 10 times root 3 over 2. So negative 5 and 5 root 3. Okay, if the magnitude of a vector A equals 7 and B equals 24, what is the magnitude of the vector? Remember, the magnitude is just a square. It's just like a Pythagoras theorem. So 7 power 2 plus 24 power 2. Just give me here the square root of 49 plus 576. So give me the square root of 25. 625. How could I know this simply without all of these calculations? Remember, just the magnitude of the vector is just like the Pythagoras theorem. And we have a famous triangle, which is 24 and 7 and 25. So here, 7, 24, and 25. This is a famous triangle. So I have 7 and 24, so the answer will be 25. So the square root of 625 is 25. Now, question number 12, we have here a three-dimensional vector, and we need to get the magnitude. So let's get the vector first. So here it would be 4 minus 1, 6 minus 2, and 0 minus 0. So it's a 3, 4, and 0. Now, the unit vector rule says that the vector over the magnitude. So let's get the magnitude. It's 3 power 2 plus 4 power 2 plus 0 power 2. Of course, it would be 0. So 9 plus 16 gives me the square root of 25, which is 5. So 3, 4, and 0 divided by 5. So it would be 3 over 5, 4 over 5, and 0. Here's it. If the vectors A, 2 and 0, 1, and B, 3 and 5, then 2A minus B. So this means I have to multiply the vector A first with 2. So 2 times 2 and negative 1 minus B, which is 3 and 5. So 4 and negative 1 minus 3, sorry, minus 2, 3 and 5. So let's subtract 4 minus 3 and negative 2 minus 5. So the answer is negative 1 and negative 7. Sorry, 1 and 7. 1 and negative 7. Here's another operation we do it in vector, which is a dot product, which means that we're going to multiply the vectors. So when you multiply vectors, you just multiply, for example, here, A vector and B vector, you're going to multiply A1 times B1, A2 times P2, A3 times P3, and you add them. And you have to pay attention for a rule that for the dot product for a perpendicular vectors equal to 0. So let me give you an example here. Now let's multiply them here. It would be 2 times 8 plus 5 times 4. So here's 16 plus 20. So equal 36. Another rule that you have to know here, how to get the angle between two vectors. We have a rule cosine theta equal A times B over the magnitude of A times the magnitude of B. So let's try to answer this question here. I have to vector U and V. So let's try to get the theta. Let's multiply first U times V. So it's negative 2 times 3 plus 0 times 3, which is 0. So the answer here is negative 6. Sorry, 6. Then let's get the magnitude. I'll get the magnitude first. For U, it would be square root of negative 2 power 2. Of course, no need to put the 0. Times the square root of negative 3 power 2 plus 3 power 2. So here is 4, square root of 4 give me 2. And 9 plus 9 is 18. What is the square root of 18? 18, it's 9 times 2, so it will be 3 root 2. So 2 times 3, 6, root 2. Now let's apply the rule. So it's 6 over 6 root 2. Cancel the 6, so it would be 1 over root 2. So what is the theta have the cosine 1 over root 2? So this means that the theta equal 45 degree. If the dot product of two vectors is positive numbers, then the angle between them is okay. Here is another rule for you. We said that if A times B equals 0, so it's 90. The theta is 90, right? They are perpendicular. So if theta is between 0 and 90, then the dot product is positive. And if theta between 90 and 180, so the dot product would be negative. And from 0 to 90, it would be acute. And from 90 to 180, it would be obtuse. So if it's positive numbers, this means it's acute angle. Now, which of the following is perpendicular to the vectors 3 and 2? We agreed A times B equal to 0 if they are perpendicular vectors. So which one of these, if I add them, if I get the dot product for them and give me 0? So here, let's try the first one. 2 times 3, 6. 6 plus 6 give me 12. So this is not correct. Let's try choice P. Also, it wouldn't give me anything. It's 3 times 1, 3. 3 plus negative 2 wouldn't give me 0. Let's try choice C. So 3 times 2 plus 2 times negative 3. Yes, 6 plus negative 6 give me 0. So here's my choice. We have here 4 vectors and he's asking me which pair would be perpendicular. So let's try to get the product for them. A and B. 1 times negative 4 is negative 4, and 4 times negative 1 is negative 4. If I add them, it gives me negative 8, so it wouldn't give me 0. So B and D, let's see, 2 times 3 is 6, and negative 2 times 3 is negative 6. If I add them, it gives me 0. Yes, so B and D. Here again for you, 2 times 3 plus negative 2 times 3. So 6 plus negative 6 give me 0. Okay, he's asking me in question 17, if we have two vectors, A and B, the value of x that makes the vector perpendicular. This means that the dot product should be equal to 0. So let's try here. 4 times 1 plus 2 times x plus 3 times negative 2. So here 4 plus 2x minus 6 give me 0. So here 4 minus 6 give me negative 2. So negative 2 plus 2x equals 0. Let's transpose the 2 here. So 2x equal 2. Let's divide by 2. So x equal 1. What is the angle between the two vectors? 2 here, 2 and 0 and 1 and 1. Let's apply the rule. Cosine theta times b over the magnitude of A times the magnitude of B. So let's get it. So here 2 times 1 plus 0 times 1. So 2 plus 0 give me 2. So here's 2. Let's get the magnitude of A, then the magnitude of B. 2 power 2 plus, of course, no need to put 0 power 2. Square root of 1 power 2 plus 1 power 2. So this is square root of 4 is 2, and 1 plus 1 is root 2. So this is 2 root 2. So it would be 2 over 2 root 2. So let's cancel. It would be 1 over root 2. So which angle has the cosine 1 over root 2? It's 45. A force of 20 Newton is applied at an angle of 60 to the direction of motion and moves an object 4 meters. The work done is... this is one of the application you have it in physics, which is the work equal force time distance time cosine theta, because you are moving with a direction. So here F is 20, the distance is 4, and cosine theta, which is 60. So it's 80 times half, give me 40. Here's the last two concepts we're going to cover in this chapter, the cross product of vector in a space. We have two vectors, they are linear combination, a1i plus a2j plus a3k, and I need to get the cross product of them. It's a sort of application on how to get the determinant of the matrix 3 times 3. So let's try to do it here. If I need a times b, so I will get the determinant for this one. How to get the determinant? I get the determinant for the first one, I. So I will just say that I don't see this row and this column unless the cross multiply. So it's A2 times B3 minus A3 times B2. I. Okay, then let's say that we don't see now the J column and the J row. Here, forget about this row and this column. So then let's cross multiply. A1 P3 minus A3 B1. This is J. Plus the last thing here for K. Let's see that we cannot see this one. So neglect this column and this row. Let's cross multiply. So it's A1 times P2 minus A2 times P1. This is for K. This is how you could cross to get the cross product of vectors in space 3-dimensional. Just two informations that you have to know. If the cross product of A times B equals to 0, this means that the two vectors are parallel. Now, if you multiply or get the cross product and you get another vector, so this means that the vector C is perpendicular on A and P. And if A and B are adjacent side or adjacent vectors, so this means that the area of parallelogram is just the cross product of A times B. Picture number 20, if P equals 3, negative 1, and 2, and Q equals 6, 3, and negative 2. What is the magnitude of PQ vector? So it's so easy. Let's do it. Let's get the vector first. It will be 6 minus 3 3 minus negative 1, and negative 2 minus 2. So 2, 4, and negative 4. Let's take the square of it. So 2 power 2 plus 4 power 2 plus negative 4 power 2. 4 plus 16 plus 16. So 32 plus 4 give me 36. So the square root of 36 is 6. Now find the result of the cross product. So this means that we're gonna get the determinant. Let's get it. I put it as a matrix. Let's get the determinant now. So here, 2 times negative 1 minus 3 times 0, which is 0. So here, 2 times negative 1 is negative 2, and negative 2 minus 3 times 0, so negative 2 minus 0, I, minus, let's go for the j. 1 times negative 1 is negative 1, and 3 times 4 is 12, so negative 1 minus 12j, plus, let's go for the k. 1 times 0 is 0, and 2 times 4 is 8, this is k. So negative 2i minus 13, this is negative 13, so minus minus give me positive, 13j. 0 minus 8 is negative 8. So 2, 13, and negative 8. Here's my answer. Again, I need the cross product. Let's get the cross product here. If I put it as a matrix, 0, 1, negative 2, and 2, negative 1, and 1. Now let's get the determinant. Let's start with I first. So it's 1 minus 1 give me 1, and 2, negative 2 times negative 2 give me 2, so 1 minus 2i. Minus, let's go for j. 0 times 1, 0. Negative 2 times 2 is negative 4, so 0 minus 4j. Let's go for k. 0 times negative 1 is 0, and 1 times 2 is 2, so 0 minus 2k. So it's negative 1i. Negative 4 minus minus give me positive, so positive 4j. And 0 minus 2k, it's 0, negative 2k. So negative 1, 4, and negative 2. So negative I plus 4 minus 2k. Here is my answer. Let's go for question 23. Find the vector perpendicular to both. So this means I have to multiply them. And let me get the cross product for them. So here is it. Let's put it as a matrix again. I, j, and k. Here's 3. Of course, there is no k, so this means it's 0. So 3, negative 1, and 0. 2, 1, and 1. Now let's get the determinant. Let's start with the I first. So negative 1 times 1 give me 1, negative 1, and 0 times 1 give me 0. So it's 0. There's I. Minus. Let's go for the j. 3 times 1 is 3, and 0 times 2 is 0. So this is j. Let's go for the k. 3 times 1 is 3, and negative 1 times 2 is negative 2. So here is it, negative I minus 3j plus 1k. So where is it? -1, -3, and 1. Okay, sorry, there's a mistake here. This is supposed to be 3 minus -2. So let me erase it. So here, -1i minus 3j plus 5k. So -1, -3, and 5. Here's my answer. Okay, question 24 is asking you if the two vectors here are perpendicular, parallel, not parallel, or opposite. Let me give you a tip here. If you are checking they are parallel, check first if they are multiples for each other or not. So let me check here. If I multiply the vector A, it would be 2, 4, 6. So it's multiple. So yes, they are parallel. Find the area of parallelograms. This means I have to use or to get the magnitude of the cross product. So let's put it first as a matrix and get the determinant. Okay, let's start with the I first. So it's 0 times 1, it's 0, minus 2i, minus, let's go for the j, 3 minus 0j, let's go for the k, 6 minus 0. So here is -2. I, -3j, and k, 6k. So -2, -3, and 6. Let's get the magnitude. So -2 power 2 plus -3 power 2 plus 6 power 2. So 4 plus 9 plus 36. You use the square root of 49, which is 7. Here's the final application on vectors, how to get the volume of the parallel pipe. We just use the same method that we used before, but we're gonna multiply the first row by the determinant. So let me show you how we can do it. So it would be here. And of course, this is absolute value. Here, A1 times P2C3 minus P3C2 minus A2 multiplied by B1C3 minus P3C1 plus B3 multiplied by B1C2 minus B2C1. This is how you could get the cross product or the triple product to get the volume of parallel pipe. And this is the absolute value. Find the value of K that makes the volume of the parallel pipe formed by the vectors equal to 10. Let's put it as a matrix first. 2, 1, 0. 0, 1, and K, and 1, 0, 2. Now let's get the cross product. So 2 times 2 minus 0 minus 1 times 0 minus k plus 0 multiplied by 0 minus 1. And of course, the last part would be 0, so I could cancel it. All of this equal to 10. And all of this is the absolute value, okay? So 2 times 2 give me 4. And this is negative k, so negative times negative give me positive. So 4 plus k give me 10. So maybe 4 plus k equal 10, or maybe 4 plus k equal negative 10. So k here equals 6, or k here equal negative 13. Which one of the choices match my answer? C.